Morning, one and all. My name is Sudhakar. We have discussed about the basic manufacturing technology, and that we are discussing about the lathe machine. In that we have covered a lot of topics. Now we are going to end the lathe machines by today or tomorrow session. So before going to discussing about the today's class, we have to recall what we have learned so far in yesterday's session, right? So in the yesterday session, we have learned about the automatic lathe and semi-automatic lathe, right? In automatic lathe, all the works are done by the machine itself. Okay? Uh, by doing this, some of the mechanisms are arranged in the lathe machine, and these mechanisms are uh, uh, working working by some of the actuators. Okay? And manpower we are not using in the automatic lathes. And come to the semi-automatic lathe, here the things are same compared to automatic lathe, but the only thing is here we are introducing human intervention is there. Why? Because for loading and unloading purpose. For loading and unloading purpose, we are introducing semi-automatic lathe. And to reduce the complexity and some another purposes, we are giving that manpower to the lathe machines. Actually, it is working automatically, that automatic lathes are, but we are giving human to do that operations, loading and unloading jobs, right? And automatic lathes are two types. One is checking lathe, and another one is screw lathe. Okay. If the automatic lathe is having a turret, that is called checking lathe, right? Here the tailstock is replaced with chuck and a turret, so that's why it is called as a chuck lathe. Screw lathe is also one of the type of automatic lathe. Okay. In that feeding is given by automatically, that's why it is called as a screw lathe. Screw lathe. And semi-automatic lathes are suitable for automatic lathes and semi-automatic lathes are suitable for small jobs. Okay, and they are very uh, done by the operator. These are done by the uh, semi-automatic lathe. We are using our operator for doing the operations. Okay. So these are the points we have covered in the yesterday's class, right? Semi-automatic lathe and automatic lathe. Apart from these, we are having so many points, but we are recalling only the main points, the key points of the automatic lathe and the semi-automatic. And the major difference we have to remember that in the semi-automatic lathe there is no, in automatic lathe there is no manpower, but in semi-automatic lathe there is a manpower for loading and unloading the jobs, for loading the unfinished product and unloading the finished product. These are done in the semi-automatic lathe. Okay. So see, these are all under the category of production lathes. Why the production lathes are designed? To meet the customer demands, right? We have chain lathes, we have given some changes on Indian lathe. So that's why production lathes are developed. Okay. And in this today's session, we are going to learn about the copying lathe. Okay. And the comparison with other types of lathes. Features of copying lathe and comparison with other types of lathes and suitability, right? So before going to start discussing about the checking lathe, how to machine or generate complex contours. How to machine or generate complex contours. So complex shapes, how can they develop by the lathe machine, and how to machine intricate surfaces. Okay. So these are the questions arranged by doing the operations on the lathe machine. Okay. So the solution is solved by using the copying lathe. So as we have discussed about this copying lathes in our types of production lathe, some of the points we have covered in that session. Now we are going to depth, that is if what are the functions of copying lathe. Okay. How to machine or generate complex contours, how to machine intricate surfaces, right? And the solution is by using the copying lathe, right? So intricate shape, surfaces, and complex contours, we are not manufactured under the general lathe machines. We need some special type of lathe machine that will be done by the copying lathe. Okay? So that should be already we have discussed that. I will remember you now. In that we are using one stylus. The stylus is traveled on the masterpiece, that is template. The template on the template it is traveled, and the cutting tool is traveled on the workpiece. By this, the manufacturing process has been done on the lathe machine. Okay, copying lathe. The copying technique was introduced in 1923 in USA. First, it is introduced in USA, that is in 1923, and it is for some time the copying lathe was invented. Right? Some of the times the copying lathe plays the main role, and in reproducing accurately the shape of the template. So this is the history about the copying lathe. It is developed in USA in the year 1923, and for quite some time the copying lathe was important in reproducing accurately the shape of the template. Copying lathe, we have already discussed that it is used for contour shapes and intricate shapes. So in that, what are the contour shapes or intricate shapes that will we have to discuss now. It uses intricately shaped parts such as pistons, worms, shafts of lathe. Copying lathes are being replaced by electronically controlled machines. Now, these copying lathes are being replaced by electronically controlled machines. Generally, they are used intricately shaped parts such as pistons, worms, shafts. So these are the intricate shapes are measured by the copying lathes. So produces pistons, worms, shafts. Now the copying lathes are being replaced by electronically controlled machines. By this process, we are easily copying the complicated shapes and intricates, right? Complicated contours. So that will be easily we can copy from the actually developed part, that is template. We can call it as a template. Otherwise, it is called as a masterpiece. So in the picture, we have observed that the copying lathe. This is also a copying lathe. We are having both elements here. The template is placed, and here the actual workpiece is placed. The template is traveled on the masterpiece. At the same time, the workpiece, the cutting tool is traveled on the workpiece. So, what are the shape here it is having? That shape will be reproduced on this workpiece. Okay, so that's why we are having two types of shapes here. One is here and one is here. So we know already the working principle of copying lathe. Now we will discuss now that copying lathe, what it is doing, it reproduces or duplicates any desired number of pieces that we already know. What it is doing exactly, it reproduces, right, or duplicates any desired number of pieces. How much number of pieces we need, that many types it will be produced. In this copying lathe, we have already known that a follower or a tracer or a stylus. Okay? A profile tracer follows the outline of a sample workpiece that will be called as a master template. It will be called as a master plate, or it will be called as a template, or it will be called as a sample workpiece. Okay? A profile tracer follows the outline of a sample workpiece. So, on the template or sample workpiece, so that will be done by the means of hydraulic controls. Yes, this is the working principle. Copying lathe it produces or duplicates any design number of pieces. The profile tracer follows the outline of the sample workpiece. Here, actually the process has been done by the hydraulic controls. The turning tool moves synchronously with the profile tracer. So the turning tool, I already told you that turning tool is here a cutting tool. You can call it as a cutting tool. It moves synchronously. Synchronously means synchronized with that movement. It is arranged with that movement. So turning tool moves synchronously with the profile tracer. And the contour of the model is transferred to the contour of the model is transferred to the work. The longitudinal feed and cross feed of the machine are regulated electro-hydraulically. The longitudinal feed and cross feed of the machine are regulated electro-hydraulically. Right? The spindle feed speed is the only function which is still set mechanically. Here, uh, the cutting tool is traveled synchronously on the workpiece. Here, the longitudinal feed and cross feed of the machine are regulated electro-hydraulically. That will be done by automatically. Understood? It will be done by automatically. So, electro-hydraulically means they are the actuators. So, these actuators handle the handle to operate the longitudinal feed and cross feed. Understood? Longitudinal feed and cross feed of the machine are regulated electro-hydraulically. And here, some manual operating is also there. That is the spindle speed. Is the function which is still set mechanically. In the working principle of copying lathe, the spindle speed is the only function which is still set mechanically. Other feedings, other cross feeds are regulated electro-hydraulically, right? So that's why the spindle speed is the only function which is still set mechanically. In the diagram itself, we have observed the operating of a semi-automatic copying lathe. The semi-automatic copying lathe means here the human intervention is there. As we have already taught that human intervention is to control the spindle speed, right? All other feedings and other mechanisms are done by the actuators, right? Okay, observe here which is the copying lathe and which is the actual lathe. here the name we are observing here, copying slide, and this is the tracer unit. This one is the tracer unit. So, and here the tracer stylus. So it will be also called as a template. And so it is carriage. In this carriage, its entire thing is fixed. And come to here, another setup. That is the workpiece is fixed. So this entire part is the workpiece. So we have observed after the manufacturing process, we have observed this is. So if the tool, the cutting tool is traveled on this lathe, the cutting tool is, sorry, the copying slide is traveled on this template. The copying slide is traveled on this template. The cutting tool, which is fixed to the copying slide, which is fixed to the carriage, right? Which is fixed to the carriage, is also moves on this one. Moves on this one. So whatever the path the stylus is traveled on this template, the same path is traveled stylus on this workpiece. So the same contours which are on the tracer unit or template, which are the template that will be reproduced on the workpiece. That will be reproduced on the workpiece. In this way, the semi-automatic copying lathe is working, right? The entire carriage is fixing the cutting tool of the original operation and the tracer unit. Okay, so the tracer unit is traveled on this template, cutting tool is traveled on this workpiece. So by this way, we are getting the same type of contours on the workpiece. So that's why we have produced complex shapes and contours. So here hydraulic servo copying lathe, right? Hydraulically operated servo copying lathe. Here the tool, this is the workpiece, oil, so this is the main hydraulic servo equipment. Oil inlet, oil exhaust, tool slide, slide away, stylus. Okay, and this one is the template. So the stylus is traveled on this template. Here, the hydraulically operated servo copying lathe operate this tool slide on this slide wheel. So the tool cutting tool is doing the workpiece. So this is the top view. This is also top view of the job. So here the operation has been done. Here the copying is coming, right? Here the operation has been done. So in this way, the operation is done. The copying lathe is happened in hydraulic servo copying lathe. So once again, I am repeating you. Here the oil inlet and oil exhaust and oil exhaust. So the stylus is traveled on the template. Based on this movement, uh, here the tool slides on the slideway. So here the tool is fixed. So with this movement, it is traveled on the workpiece. So we are getting the exact. We are getting the shape, right? So that's why we are doing the copying from the hydraulic servo copying lathe. So this is the operation of semi-automatic copying lathe, and this is hydraulic servo copying lathe. The picture we have observed that slant bit copying lathe. So slant bits hold the heavy jobs, heavy work pieces. They can hold and doing the works. Copying lathe. We also have the copying lathe. And here we have some limitations in the copying lathe. That is, the masterpiece is to be produced first by other means. Right. So this is the main question arised while doing the copying lathe. First, we have to develop the masterpiece. But the complex and contour shapes are developed by the copying lathe itself, as we have done so far, right? But here, first, first we have to do the masterpiece. That masterpiece also having a different complex contours and complex shapes, right? So that should be developed in other machining operation, right? So that's why it is having the limitation. So it has to be produced by other process. And the masterpiece surface properties dictate entire batch of production. Masterpiece surface properties dictate entire batch of production. So the surface properties dictate entire batch of the production of the masterpiece. So that's why we have to develop the masterpiece in the correct way, right? Then only we can get the other products in the good manner. Otherwise, we will lose the entire thing. Okay, so that's why we have to develop the masterpiece correctly. That why, because the surface properties dictate the entire batch of the production. Okay, let us summarize before going to discussing about lathe motion. In this now we have discussed about the copying lathes. This generate complex contours on the surface. A master template is required for generating the shapes. Copying lathe means generate complex contours on the surfaces. The master template is required for generating the shapes. The stylus or tracer is responsible for generating the profile. Stylus or tracer is responsible for generating the profile. So copying lathes are suitable for batch production. So in automatic lathes are suitable for mass production and batch production. Semi-automatic lathes are suitable for job production. And here the copying lathes are suitable for batch production. Okay. So copying lathes generates complex contours on the surfaces. A master template is required for generating the shapes. A stylus or tracer is responsible for generating the profile. These are suitable for batch production. Right? Now these are replaced by CNC machines. Now the copying lathes are replaced with CNC machines. As we have already taught that the CNC machines have a programming language. With that programming, actuators are working. Based on that actuators working, the machine is operated. So it is fully automated, right? CNC machines are fully automated, and what are the complexity had to be changed while doing the operation, that will be done by the CNC machines while doing the operation itself. Okay, so that will be coming in the next session also. So now before going to another topic, let us do some questions on the copying lathe. Copying lathes are now replaced by, just now we have discussed that the copying lathes are now replaced by CNC machines. That will be can answer easily for this question. The tracing element in the copying lathe is, we know that the stylus or tracer used for the tracing element. So we can simply tell that the tracing element in the copying lathe is stylus. Stylus have how much 2 degrees of freedom of motion, 3 degrees of freedom of motion, 4 degrees freedom of motion. So generally the stylus having 3 degrees of motion, that means it will be moving x, y, z directions in linear directions only, not in rotational movements. So that's why it is having 3 degrees freedom of motion. So explain the hydraulic serving copying lathe, system for a lathe, state the applications of copying. Now we are going on this. So now we are moving to discussing about the comparison of the engine lathe, semi-automatic lathe, and automatic lathe. We have learned so far about the engine lathe, the semi-automatic lathe, and the automatic lathe. If we compared some things, we will get clarified of these three lathe machines. Right? We'll get some clarification. What are the engine lathe is having, and what are the semi-automatic lathe is having, and what is the automatic lathe is having. So, decide the suitable lathe for a given job. So before going to compare this, we have to, and also we have to do some suitable lathe for a given job. Compare engine lathe, semi-automatic lathe, and an automatic lathe. So based on this comparison, which part is, which production is suitable for which machine? That will have to decide based on the comparison. We will get the clarification also. Which part is to be produced on some particular machine, that should be on system lathe, or that should be on semi-automatic lathe, or that should be on automatic lathe. Okay, so those points will be get clarified after doing comparison. Right. Before, right, first ranking wise, right, as we compare ranking wise, production rate ranking. In this, the automatic lathes are in the highest rank, and the semi-automatic lathes are in the higher rank. Engine lathe is on the lowest rank. Production rate. What we have to observe here, production rate rankings. Production rate means uh, we will produce the products within less time, and in these three machines, which is the machine we are going to produce the products within the less time. We have learned in our earlier sessions that automatic lathes are producing the products within the less time, right? So here there is no human intervention in there, and all the things are done by the automatically. So that's why it is on the highest rank. And the next thing is semi-automatic lathes. The next thing is semi-automatic lathes. So semi-automatic lathes are in higher position compared to the engine lathe. It is between the automatic lathe and engine lathe. It is also producing the products within the less time, but it is compared with the automatic lathe, it is having less number, but compared to the engine lathe, it produces the more numbers. Compared to the automatic engine lathe, semi-automatic lathes are producing products with more, and but compared to automatic lathes, it produces the products less. So that's why these in the moderate are in the middle grade, right? So automatic lathes are in highest position, semi-automatic lathes are in higher position, engine lathe are in lowest position, right? Engine lathe, we know already that here the skilled operator is required, and if the manpower is not available, the production has been stopped, and there is no production takes place. So that's why less number of products produced within the time, right? So that's why Indian lakes are at the lowest rank. So compared to these three machines, the automatic lakes are in the highest position, semi-automatic lakes are in the middle position, and engine lakes are in the lowest position. So this is based on the production rate. Tool holding capacity. So we know already that the tool holding capacity based on the carriage tool holders, right? So that will be, we will point out each lathe based on the tool holding capacity. Okay, automatic lathes. In the automatic lathes, it can hold a large number of tools at a time. Automatic lathes can hold large number of tools at a time. That is 30. So 30 tools it can be handled at a time. That will be on the generate or that will be that will call including in the separate the cross slide opposite to the cross slide. Okay. So uh, after adding these tools, we will get the number is that. So the automatic lathes are holding the tools within at a time is 30. And it can operate more number of tools in machining action simultaneously. And also in automatic lathes, more number of tools in machining action simultaneously, 3 to 5. More number of tools in machining action simultaneously, 3 to 5 will be done. More number of tool posts. So if we want to hold the 30 tools, we need more number of tool posts also, right? One square tool post hold only 4 tools at a time. So, and the magazine turret is having only 6 tools. So that's why we need more number of tools in tool posts. So this is the automatic lathe tool holding capacity, right? So it can hold large number of tools at a time, more number of tools in machining action, simultaneously 3 to 5 operated, and more number of tool posts also. Semi-automatically, it can hold 10 to 15 tools at a time, right? Compared to automatic lathe, it can hold 10 to 15 tools at a time. 1 to 3 tools in machining action simultaneously. 1 to 2, 1 to 3 tools. In that, 3 to 5 tools. In this 1 to 3 tools in machining action simultaneously. And here we need 2 to 3 tool posts. 2 to 3 tool posts. Observe that turret 1, 2, 3, 4, 5, 6, 7, 8. 8 tools, 8 cutting tools on that turret. And it needs some square tool posts. In that also we are fixing some cutting tools. So that's why it can hold 10 to 15 tools at a time. And it can operate one or three tools in machining action simultaneously while doing the operation. And 2 to 3 tool posts are required in semi-automatic lathe for holding this 10 to 15 tools. We come to engine room. So as we know that engine lathe can hold only 4 tools maximum at a time because it is having only one square tool post. With that square tool post, it can handle only 4 tools at a time. And but sometimes it is having we are doing a drilling operation. We can hold the full bit on the tail stump, right? So hardly it can operate 2 tools in machining action simultaneously. One is doing the turning operation or some machining operation, and other one is doing drilling operation or reaming operation. So simultaneously it can operate 1 to 2 tools, right? Hardly it can operate 2 tools in machining action simultaneously. In this engine lathe, it is having only one tool post, but sometimes tail stocks holds one tool. Okay, So this is all about the tool holding capacity. Once again, I am recalling an automatic lathe. It can hold 30 tools at a time. In semi-automatic lathe, it can hold 10 to 15 tools at a time. And in Indian lathe, it can hold a maximum 4 tools at a time. And in automatic lathe, 3 to 5 tools operate at a simultaneously. In semi-automatic lathe, one or three tools operate at a time. In engine lathe, two tools can operate simultaneously, right? And here in automatic lathe, number of tool posts required to hold the tools. In semi-automatic lathe, 2 to 3 tool posts required to hold the tools. In engine lathe, only one tool post is required, and sometimes the needle is hold in the tailstock, right? And we are moving to the power requirements as the automatic lathes are automatically operated. That's why it requires, we can easily tell that it requires more power compared to the other lathe machines, that is semi-automatic lathe and engine lathe. It requires more power, right? So it requires more power, that means 10 times greater than the 10 times of engine lathe, that much of power required in automatic lathes. And here spindle rotates at higher speed, that is 3000 rpm. Here the spindle also rotates at the higher speed, 3000 rpm. Automatic lathes requires more than 2 motors for getting different motions. So here the power requirement is more because automatic lathes requires more than 2 motors for getting different motions. So that's why automatic lathes requires more power. That is 10 times of engine lathe. Spindle rotates at higher speeds, 3000 rpm. The automatic lathes requires more than 2 motors for getting different motions. And for the same size of the machine, semi-automatic lathes compared to the engine lathe, it requires 5 times of power more than the engine lathe, right? So why we are comparing with the engine lathe? Because we have developed first engine lathe, but to reduce some drawbacks on the engine lathe, we are developing production lathe. So that's why we are getting these points. In the semi-automatic lathe requires much power, that is 5 times of engine lathe. And here spindle rotates at a higher speed. In that we are rotating the spindle at 3000 rpm, but in semi-automatic lathe, the spindle rotated at 1500 rpm. Semi-automatic lathes requires more than one motor. Semi-automatic lathes requires more than one motor. In the automatic lathes also, it is having 2 motors. For the same size of the machine, coming to the engine lathe, for the same size of the machine, coming to the engine lathe, it requires less power motor. Okay. So why are these discussions we are now? Because based on these requirements, based on these differences, uh, we are selecting the suitable machine for suitable work, right? That's why we have compared all these points. So engine lathes requires less power motor. We know already. Spindle rotates at moderate speeds, 900 rpm, and it operates with only one motor. Okay. So these are the power requirements in engine lathe. Okay. In automatic lathe, the power requirement is 10 times higher than the engine lathe. And in automatic lathe, the spindle rotates at a 3000 RPM. And in semi-automatic lathes, the power requirement is 5 times more than the engine lathe. And in this, spindle rotates at 1500 RPM. And in automatic lathe, they're having two motors required for doing the rotations. And in this semi-automatic lathes, it requires one or two motors. And at the same way, and as in the engine lathe, it can operate with only one motor. Okay, so these are the power requirements are needed in the engine lathe. And production variety. Production variety means what are the types of products are manufactured on the engine lathe. Okay, so based on our requirement, based on our customer demand, we have developed that variety of products. Which lathe is produced good variety of products that will be coming now. So that is in engine lathes, we can produce large ranges of varieties and sizes. Semi-automatic lathes, medium ranges of varieties and sizes. Automatic lathes, limited ranges of varieties and sizes. Because engine lathes are operated manually. Every time the fresh design will come, it will doing, the man will do that variety of operations. But productivity is less, but variety is more, and sizes are uh, highest. As in semi-automatic lathes also medium range of varieties and medium sizes will be come. But in automatic lathes, limited ranges of varieties and sizes. Why? Because in automatic lathes, the operation is fixed. The operation is fixed because the program is fixed. Based on that program itself, the cutting tool is operated. So we are getting the identical parts every time. If we want to change the variety, we have to change the program. That's why we need another program. So again, it will produce the same identical parts with that design. So that's why in automatic lathes, we are getting the limited ranges of varieties and sizes. Translatory motions, automatic lathes, fixed with servo motors. Semi-automatic lathes are done by the chasing screw. Engine lathes is moving by the lead screw, right? So we have already known that the mechanisms are operated by some actuators, the motors, as we have discussed in automatic lathes. So that's why in automatic lathes, the servo motors are operated. In semi-automatic lathes, chasing screw is required for operating the machine. In engine lathes, the feeding is done on the lead screw mechanism or split nut mechanism. So these are the translatory motions in automatic lathes, semi-automatic lathes, and engine lathes. In automatic lathes, servo motors, semi-automatic lathes, chasing screw, engine lathe, lead screw. Right? Finished job. Automatic lathes. Finished job. What are the output will come from the automatic lathes? High precision products will be come from the automatic lathes, and complicated shapes will be come from the automatic lathes, and we are getting the large accuracy. Accuracy is good compared to the other lathe machines, and uniform jobs throughout. All the identical parts are uniform throughout after coming from the automatic lathe machining operation, and there is no inspection for all the products. Just to check the random operation requires random inspection only. In semi-automatic lathes, the compared to the automatic lathes, precision is good, and we can develop the moderate shapes, right? And it will be medium accuracy. Uniform jobs throughout the batch requires batch inspection. So uniform jobs, so it is required and requires batch inspection. In engine lathes, Precision requires skill, general shapes are produced, low accuracy, uniformity of the jobs not assured, and it requires 100% inspection, compulsory 100% inspection of the all the product because it depends on the operator skill. That's why it needs 100% inspection, and uniformity is not uh, assured because the operator is different modes at different time levels. That's why we are not getting the uniformity. So for that reason we require 100% inspection. That's based on that operator skills, and it will give the low accuracy also. So we are doing the general shapes on the engine lathe. Suitability, to which type of production these lathes are suitable, right? So the engine lathes are suitable for job production, and semi-automatic lathes batch production, automatic lathes mass production. That's we have already discussed that. Engine lathes are suitable for job production, semi-automatic lathes are batch production, automatic lathes are mass production. And labor. The labor is required skilled labor in tool setting, job setting, and machining in engine lathe. Automatic and semi-automatic lathe requires skilled labor for tool setting only, not for job setting and machining operation. So these are the comparisons we have to do now. So engine lathes are, let us summarize today's session. Engine lathes are suitable for job orders. High production rates can be achieved by using automatic lathes, and complex shapes can be machined by using semi-automatic and automatic lathes. Automatic lathes are costlier. So we can do some quiz question for machining spiral jobs. Which lathe is recommended? Automatic lathe. An industry has to manufacture socket screws of different sizes and batches. Pick up suitable lathe, that is semi-automatic lathe. An automobile brake drum needs to be repaired by machining. Which lathe is suitable? Engine lathe. So these are the frequently asked questions. So today I'm going to end this session. So we will discuss another topic in tomorrow's session, right? Thank you.